All right, let's talk about something that's absolutely critical for database performance. But honestly, for a lot of people, it's a total black box. SQL Server's memory. Today, we're going to crack that box wide open and give you a clear look inside. So here's the plan. We're going to start with why this all matters in the first place. Then we'll peek under the hood at the architecture. We'll meet these little internal managers called clerks, figure out how to see what they're up to, and then wrap it all up with two super important best practices you can take back to your own servers. Okay, first things first. To really get a handle on SQL Server's memory, you have to understand the one fundamental problem it's constantly trying to solve. And that's a gigantic speed gap baked right into your server's hardware. And when I say gigantic, I mean it. Check this out. Getting data from a disk is measured in milliseconds. That sounds pretty fast, right? But getting that same data from RAM, that's measured in nanoseconds. It's not just a little faster, it's thousands of times faster. It's not even a fair fight. So, for SQL Server, the name of the game is simple. Get data into RAM and keep it there. So, that leads to the million-dollar question, doesn't it? How does SQL Server manage this incredibly precious resource? Well, it sure doesn't just hand the keys over to Windows and hope for the best. No way. It has its own highly specialized operating system built right inside it, the SQL OS. And its entire job is to manage memory like a hawk to keep those queries flying. So let's zoom out and take a look at the big picture. You see, when we talk about SQL Server memory, it's not just one big bucket. There are a few key layers you've got to get your head around. Down at the bottom, you've got the physical hardware, the actual RAM sticks plugged into your server. But an application like SQL Server doesn't talk to that directly. It works within this abstract layer managed by Windows called the virtual address space. And it's inside that space that SQL Server carves out its main territory, a huge area known as the buffer pool. You know, the easiest way to think about the buffer pool is to picture it as SQL Server's own personal, super fast library. Anytime it has to make that slow trip to the disk to read a page of data, it brings back a copy and puts it on a shelf in this library. Why? So the next time a query needs that same page, bam, it can just grab it from the cache in nanoseconds. No more slow trips to the disk. But, you know, a giant library can get pretty messy if it's not organized, right? So how does SQL Server manage this huge pool of memory? Well, it's not a free-for-all. It's all meticulously organized by these internal components called memory clerks. Just think of memory clerks as specialized accountants. Instead of every single feature inside SQL Server fighting for a piece of the memory pie, each component, like the part that stores query plans or the part that handles locks, it has to go to its own dedicated clerk to request memory. It keeps everything orderly. And this brings me to a fantastic analogy from Jayanth Karup that just perfectly illustrates this. He said that different operations have different memory clerks, just like different types of criminals will have different cell blocks. I love that. Let's run with that prison analogy. If SQL Server memory is the prison, then the buffer pool, where all the data pages live, that's your general population. It's the biggest area by far. But then you have all these other specialized memory needs, right? Like query plans, locks, in-memory tables. They each get their own dedicated cell blocks, managed by their own clerk. So, under a normal workload, your server's memory might look something like this. The buffer pool, our general population, is taking up the lion's share, maybe 85% of the memory, just holding on to cache data. And then you've got smaller but still critical slices for things like the plan cache. But here's the really cool part. This system is completely dynamic. Let's say we suddenly create a huge in-memory table. The clerk for in-memory OLTP goes and requests a massive chunk of memory. And to grant it, SQL Server actually shrinks the buffer pool to make room. It's like the warden clearing out an entire wing of general population to build a new high-security unit. This internal negotiation happens constantly, all behind the scenes. Okay, so this dynamic system is great, but is it just a black box that we can't see into? Absolutely not. SQL Server gives us an incredible set of tools to see exactly what these clerks are up to. They're called dynamic management views, or as you'll always hear them called, DMVs. And the number one DMV you need to know for this is sys.dmos memory clerks. Think of this as the warden's official ledger for all the cell blocks. You run this query and boom, you get a direct breakdown of who's using what. So here, yep, the buffer pool's the biggest user, no surprise. But look, the lock manager is holding on to a full gigabyte of RAM. We can even see exactly how much memory is being used by cached ad hoc query plans. This is pure gold. And we can go even deeper. Using another DMV, sys.dmos buffer descriptors, we can actually peer inside the buffer pool and see which specific databases are taking up the most space in our library. And in this case, our sales DB is clearly the star of the show, consuming almost 3 gigabytes of that cache all by itself.
Okay, so now you get the architecture and you know how to monitor it. That's fantastic. But let's shift gears from just watching to actually doing. Let's talk about 2 fundamental settings that can dramatically improve the stability and performance of your SQL Server.
First up, lock pages in memory. Now, this is a Windows permission you grant to the SQL service account, and what it does is powerful. It essentially tells the Windows operating system, hands off, this memory belongs to SQL Server. Don't you dare move it to the slow disk-based page file. This prevents these awful performance cliffs where Windows gets aggressive and pulls the rug out from under SQL Server's memory management.
All right, best practice number 2 is setting a ceiling with max server memory. By default, SQL Server is, well, it's greedy. It's designed to be. It will try to consume almost every last bit of RAM on the server. And while that's great for SQL Server, it can starve the operating system and any other essential services running on the same box. So, the solution is to cap it. A common and very sensible rule of thumb is to leave about 4 gigabytes or 10% of your total RAM for the operating system to breathe. And you just pick whichever of those 2 numbers is bigger. This creates a protective buffer, ensuring the whole server remains healthy and responsive, not just your database engine.
So let's bring it all home. What have we uncovered? Well, first, the whole game is about keeping data in fast RAM and off slow disks. Second, SQL Server's main weapon for this is the buffer pool. Third, that pool is managed by specialized accountants called memory clerks. Fourth, this isn't a secret. You can use DMVs to see exactly what's happening. And finally, you can and should be proactive by setting lock pages in memory and a sensible max server memory limit. And that leaves us with a final thought. We've given you the tools to look inside what was once a black box. So when you go run these queries on your own servers, what are you going to find? Will it be the buffer pool as expected? Or will another clerk, maybe for ad hoc plans or query reservations, reveal an unexpected memory hog? The power to find out is now in your hands.